If it starts with a metal or it starts with an NH4, it is ionic. Do we use prefixes? No. So you're basically just going to write the name of the cation, and for the cation you have to ask yourself, is it in the gray zone or is it not in the gray zone? If it's in the gray zone, what do you use? Roman numerals. If it's not in the gray zone, no Roman numerals. Yeah, of course. Yeah, where have I put it? I just had one a minute ago. That's okay, I'll find another one. There you go. So there are three choices for your cation. Either you're going to have NH4. Where do you find the name for NH4? That is on your pink sheet. And you should really be familiar with that one because it really is the only super important polyatomic cation. Okay? Apparently when I wrote this, I was coloring things both red and blue. So a monovalent metal is basically not in the gray zone. And there is no Roman numeral, just like we said before. If it is in the gray zone, then you need to have the name of the metal and then the Roman numeral in brackets, and that tells you the charge of the metal. Does it tell you how many of that metal there are? No, the Roman numeral does not tell you the number, it tells you the charge. Okay, the Roman numeral tells you the charge. Then you're going to write the name of the anion. If it's monatomic, that means a single element, one capital letter. Then you're going to look up the element name, like if you just had like, you know, Fe3O2, you would look up the O and say ox what? Oxide. Okay, but if you have a polyatomic ion, FeNO3, you would just look up the name on the pink sheet. Okay, which would be NO3 is nitrate. So that would be iron 3 nitrate. What? NO3? Yes, it is. I promise. I was going to say that's one of our most common ones. It better be there, otherwise I've done something very, very wrong. Okay, you can ignore this bit about hydrates unless you're doing the enriched stuff. Now, how do you know if you're going to use the prefix? Molecular is made of two nonmetals, so it is going to start with a nonmetal, but it's not NH4. It does not start with NH4 because if it starts with NH4, it is ionic. And if it starts with a metal, what are you going to use? use the prefixes. Okay? Now, if you're not doing acids, because that's part of this is a black diamond thing here, right? So you don't need that unless you're doing that. Okay, so that is what you do when you are naming compounds. So this would be what you are doing. Is that on page 75 or 76? I can't remember. So if you're naming compounds, that would be on the first sheet of the review. Okay, first page of the review. So you can practice naming compounds there. Now the second page of the review is about writing the formulas. And again, you need to know that if it's ionic, it starts with a, what does it start with if it's ionic? It starts with a metal, or what? Metal or NH4. If it's molecular, what does it start with? It starts with a nonmetal. And that is not, but not NH4. When it is ionic, how do you write the correct formula? You have to find the charge of the cation, find the charge of the anion, and then you're going to balance the charges to make the compound neutral. Balance the charges to make the compound neutral. You can ignore the part about hydrates. Here's a few things to check that people get wrong. After you've finished writing the formula, you're going to check, did I draw brackets and I have no number on the outside? Is that okay? No. So I would write it without brackets if I don't have more than one of them. Is it okay to write OH without brackets? Like this. No, because what I have is I have Mg, and I have an O and an H, and I have an O and an H. If I just have this, there's only two H's, not two O's. If I have this, then it applies to both of them. So this is a yes, this is a no. Do not put a Roman numeral in the formula. When you're writing your test, the formulas will be on one side and the names will be on the other side. And sometimes it'll be nice, like if you're tempted to put in a Roman numeral in the formula, you can look on the side where I've written all the formulas and say, did Ms. Spence put Roman numerals in any of the formulas? Gosh, she didn't. Maybe I shouldn't either, right? You can do that. You can totally go and like check through how I did things. Where did she put the brackets? Right? Oh, she did not put brackets when she just had one of an ion. So you can kind of use one side of the test to help you with the other side if you want to. Do not ever put charges when you're writing the formula of the compound, and make sure that your numbers are small, okay, and that they're at the bottom. Alrighty? Could you use half an hour to practice? Would that be helpful? If you do not need a half an hour to practice, Then in your new book, you could do pages. Well, I mean, honestly, at some point we're going to do pages 1 through 13. So you could just work your way through that as far as you get. Okay, so if you don't need review, pages 1 through 13. But obviously you don't have to finish it all. Is there anyone who needed a copy of the review? Does not have one? Hi. Sure, yeah. They don't tell me anything. I don't know. Hi. The Unit 5? Ah, yes. Is there anyone else who is away, did not get Unit 5 yet? If you did not get Unit 5, we can over here. You have it. I have no control. I can't, I don't not how to actually corrupt. I wish it did, but I don't. Yeah, I'm sorry. Oh, yeah, you should get Charlotte's phone number and maybe half an hour before school, before 12. Text her. Say, hey, Charlotte, are you coming? Yeah. Good Friday. And if anyone is still working on quizzes, that's great. You can do some of them today. I You get the on the test, yes. Okay. Yes, you guys get the pink sheet and a periodic table on the test. If you are doing the acids and hydrates, you also get the extra list of ions. Okay. Oh, you can't even hear anything. Number one, I didn't hear it. And number two, like, it doesn't, it's not far away. No, no, no. You have to tell us right there. Yeah. I'll double check it. So if there's anything, I'll let you know.
or at least this a little less chaotic. The review. I will be with you in a moment. I'm not quite sure where this is. Okay. Sorry, I'm just looking for my glasses.
go. There. What is DNA and how does it work? Well, first of all, does anyone know, and this is a huge, horrible word, this is I guess I should make it a black diamond word. If you just know it as DNA, that's fine. If you want to learn its full name, does anyone know its full name? D is for deoxyribo, and then we have nucleic. By the way, where do we find DNA? It's in the nucleus, and guess what? It is called deoxyribonucleic acid because it is related to the nucleus. Nucleic, and then of course the A stands for acid. But that is a black diamond term, okay? If you just know it as DNA, that is perfectly good. What is DNA? DNA is it is a molecule. Do you see why we did chemistry before biology? Yeah. DNA is a molecule. It is a bunch of what stuck together? Atoms. These atoms combine to form the shape of a long spiraling. Do you guys know what a spiral is? Yeah, it's a long spiraling ladder. Do you guys know what a rung is on a ladder? If you have a ladder, these things here are the rungs. So those are the rungs of the ladder, and the things on the side are just called the sides, okay? Because we will be referring to the rungs and the sides. What is the function of DNA? It is to act as a blueprint. Do you guys know what a blueprint is? It's like the instructions for something, right? It's like it shows you how everything's put together. If you're an architect, you might make a blueprint for a house that shows the builder how to put it together. Or you might also consider it to be like a recipe. And it is the blueprint or recipe to build an organism, like a tree, a dog, or a dinosaur. Now, amino acids. Do you need to know all the names of the amino acids? No, you do not, okay? They're just here to give you an idea of some of the weird names and some of the shapes and some of the molecular structures. They're just kind of interesting to look at, but you don't need to know them, okay? You do not need to know names of amino acids. Amino acids are tiny little chemicals inside our bodies. They are often referred to as the building blocks of life. Does anyone know about how many types of amino acids there are? There is about 20 different types of amino acids, each with their own unique shape. And you can see over at the right, there's all sorts of weird little different shapes. Okay, there's triangles, there's rods, there's all kinds of different shapes. The neat thing about amino acids is that they can be attached to each other kind of like Legos to produce an endless variety of larger particles called proteins. So, if you have a Lego kit, the little pieces of Lego are like the amino acids, and the finished model, that would be like the protein. And here's just some pictures of what proteins might look like with all the little amino acids stuck together. Amino acids make up proteins. Proteins and other chemicals make up living cells. The cells make up tissues. The tissues make up organs. Okay, so you might have some liver tissue, and if someone needed to, like, say, take a, say you were getting tested, your liver was getting tested, they might need to take a biopsy of your liver. That means they take a small little sample of it. That would be liver tissue, but the whole organ is the liver. And when you put all the tissues together and all the organs together, you get a living creature. Now, there were 20 types of amino acid, but because you can combine them in so many different ways, there are how many different kinds of proteins? Millions of different kinds of proteins that make up our body. And so we have some little pictures here just to say, look, here's some various shapes you could have. In order to function properly, they must be the perfect shape. Can you imagine if you had salad tongs and they were shaped like a sphere? Let's say you had a sphere and you tried to use it as a pair of salad tongs. Would it work very well? You'd be like, okay, I've got this ball. You could smush your salad with it, maybe, but it would not work properly, because in order to be good at scooping salad, you want something that kind of, does this. And if it doesn't do that and it's not shaped with two pieces that can come together, then it's not useful. And just like that, the proteins have to have a specific shape so they can do their job. One of the functions of DNA is to tell the amino acids how to line up and form themselves into the perfect protein shapes. Here is a simplified model of DNA. Here is our ladder. And you can see that the steps of the ladder, remember the word for steps of the ladder, those are the rungs of the ladder, are made up of how many different types of chemicals? How many different ones do we have? We have 4. Yeah, 4. And they are represented by the letters A, T, G, and C.
Good morning, Bernie Mountain. This week, the Racial Equity and Global Justice Club is going to be sharing information about a different cultural event that will take place in December. December 8th is Hopi Day. Hopi Day is a Buddhist tradition that marks the day that Siddhartha Gautama, who legend says founded Buddhism in India, became the Buddha. December 21st marks Winter Solstice Day, which many indigenous people celebrate, as it is the day of few hours of sunlight, and the days ahead begin to be brighter. Thank you.
Okay, so homework is to study for your test, practice, practice, practice. If you are still working your way through the quizzes, then your job would be to study for whichever quiz you have coming up next. Okay? So study for your test. We'll look more at this DNA next day. Okay?